Hey everybody, this is Alex Merced, and welcome to this special workshop. We're going to be talking about how to create a data lake house in 60 minutes. And it's going to be a lot of fun. Now, of course, before doing this workshop, ideally you would have your own dremiocloud environment already spun up in order to follow along with the exercise. With no further ado, I want to introduce Isha Sharma from Product. And Isha, the stage is yours.
Awesome. Thank you, Alex. Thanks everybody for being here. Today we will be walking through building an iceberg lakehouse in 60 minutes, probably even less because it's that easy. And before we get started, I'd love to do a quick overview. I'm guessing for those who have joined the workshop, you know a little bit about Iceberg, but Apache Iceberg is your open table format that unlocks your SQL database-like capabilities directly on your lakehouse. Right, so that's your DML, like insert and update and delete, and things like time travel. But it also allows you to keep your data in your lakehouse, still get the performance you get with products like Dremio, and the most important part is keeping your data in an open format, which it allows you to do. Right, and as you can see, there's a lot of great companies and folks that have contributed to it as well as have adopted it. So it's a fantastic technology. We're going to get into it today. We're going to see how flexible it is and how easy it is to really get started with. So today we'll be walking through a quick overview of the Dremio application for those of you who aren't familiar. And then we will get into creating that iceberg table, populating it with data, and then updating that table without seeing an impact to production. And I'll show you and explain to you how exactly you can do that without spinning up an entirely separate environment. And then on top of that, we all know performance is important. You can't have those queries and dashboards running forever. And so to do that, we'll walk through how you can configure a reflection on your table or on your view to get that performance, that sub-second performance that you're looking for. And all of this without spending too much more than an hour. So let's get started. I'm going to pull up the Dremio application here. When you log into Dremiocloud, you'll land on a page that looks like this. And basically, what we're going to go into is Sonar. A Sonar project is the workspace that you'll be working in. I've only got one in this organization or in this account. And the three most, prominent components of our application here are the screen we're on right now, which is your catalog page. And so when you created your project, you were asked for a catalog name. And I called mine Workshop, which is what you see right here. Right now it's empty. We'll get to putting a table and a folder in there in a minute here, but what you'll notice is that right next to the catalog name, you've got this tag that says main, right? So your catalog is a ready and built for Iceberg catalog. That's what's going to make this super easy. But along with that, you've got this capability of data management, sort of what we call dataascode. Right? And that means you can manage your data and your catalog just as you can application code, right, using Git. And so main here means that you're on the main branch. And if you expand this out, right now there's not much of anything, but you do see that I've been in here doing things, right? And so this is the ability for you to look at any point in time, right? And on top of that, something that we're going to do in a bit in this workshop here is make changes in an isolated environment, but it's a virtual environment. You're not making any copies to make that happen, right? And so we'll get into more details of how all of this is really powerful and can get you started very quickly and can make your life a lot easier and your environment's a lot less costly, right? So specific to this workshop, we'll be working with a data set that we have in our samples bucket, right? So anything below your catalog is a source that you can add. That can be object storage, that can be a database like we have here, but we'll be working with a file that I have in S3, and it'll be this NYC taxi trips .csv. Notice that I haven't registered this in Dremio yet. It's not a physical data set here, and I'm going to leave it that way for the purposes of this workshop. All right, so that's the catalog area. The SQL runner, there's the second tab here, and that's where we're going to be spending a whole ton of our time, so I won't take too much time right now going through it. But the last component here is our jobs page, right? And our jobs page shows you every query, every internal job that Dremio has executed, any any job that's run, whether that be from the Dremio UI or a completely different application. And so you get an entire collection of these jobs here so that you can see exactly what's going on in your project across your users, across the different types of jobs. And when you click into these, you get even more information about the job that ran and exactly what happened, right? So without further ado, let's get down to creating that iceberg table we've been talking about. So I'm going to drop a script that has all of the SQL statements that I will be working through. And I'm going to drop that into the chat right here. So y'all should have access to that. And so, like I said, this has all of the SQL statements I'm about to run. What you will want to do is replace the catalog name everywhere that has the catalog name parameter. Replace that with the actual catalog, the name of your catalog in your project. So mine is called workshop. So I've done that replacement already, and I've got all of my statements saying, pointing to the workshop catalog. All right, so that might take you a second. But go ahead and do that. And in the meantime, let's get started here. So the first thing that you all want to do is usually create some sort of a folder. We're going to call it my folder. Typically, it's called something more meaningful than that, right? It might be your different lines of business. It might be the different layers of your data. It's really up to you. We provide you the flexibility to organize your data however you want to organize it. So for now, let's create this folder where we're going to put our iceberg table. And so it's as simple as running a create folder command. And if I hit run here, and I'd like you guys to do the same, follow along with me. And that is pretty quick, but if you expand your catalog on the left here where your data panel is, you'll see that the folder we just created has appeared. All right. And so now for the exciting part. We've created the folder, we've done the setup. Now we're going to create this table. As I mentioned, we're going to be working with New York taxi trips data. So I'm going to call my table NYC trips. Okay, and I've specified all of the columns in that file I showed you guys earlier, what I want them to be called basically, and then the data type that I want to specify. So this is like your basic create table statement. And what this will do is land that table in the folder we just created in the catalog that you have out of the box in your project. All right, so go ahead and hit run there. And now if I expand the folder that I have on the left-hand side of my SQL runner, you're going to see that tables appeared with all of the columns that I specified with the right data types, all of that fun stuff, right? And you've done that this is your iceberg table. You've done that in a single regular create table command without any extra configuration. And what's happened underneath the covers is that we've done the iceberg table creation for you. And what that means is there's a metadata file that's been created that has indexed the table, that knows basically what the table is about. All right, so no additional configuration. It was as simple as that to actually create an iceberg table. Now I know it's empty, so we can fix that as well pretty quickly, but we'll be using the copy into command to fill up that table with data. And how this is going to work is I'm pointing to the file in my S3 bucket, as I showed you guys earlier. It's a single file. You can do multiple files, right? So that's something that's definitely a practical use case, and you can specify it that way as well. And so I'm going to go ahead and run this copy into command to copy the data from the NYC taxi trips .csv that was in my S3 bucket. We can see the same thing. Actually, we won't see the same thing here because it hasn't been registered in Dremio, but that's okay. And I'm going to go ahead and run this. And while that's running, it's a pretty sizable data set, so it will take a second here, but there are alternatives to copy into, right? You don't have to use that. If you already have the data set registered in Dremio, you could have done a create table select as. That would have been simple enough as well, right? And so there's a few different options to go ahead and do this. And it works on CSV and JSON files, and it doesn't have to be just one file, right? We can read multiple files as well and do the copy into a single command. So that's done. The results have told me that I've got 1 million rows copied into the table that I've created, right? But I'm a stickler. I like to verify things. So I'm going to run both of these commands here. The first one is to just do a count star on the table that we've been working with, that we've created, right? And so there's that. And then the second command here, I just wanted to, well, the first one confirms 1 million rows, that's solid. The second one gives us a little bit of a view into what this data set actually looks like. We didn't look into that when we started this entire journey. And so, the columns you kind of already knew, we created that table, but the data itself, the things that we'll be looking at as we move on to the next step of this workshop is specifically this passenger count column. It naturally, as it sounds, contains the number of passengers that took a ride in a New York taxi. And so our scenario here is that, there's a couple of places in this data set where the passenger count is 7, but we come to realize that we don't actually have a car that picks up 7 people or that can fit 7 people if the driver's in there. And so, digging through a few things, that's a bit of a glitch, and we've got to adjust the passenger count in the data set to be the rightful count, which is 6, right? So that's what we're going to end up doing in our next step, updating our data set. But the natural problem is that you don't want to do something like that. This is a smaller change, but you don't want to do grand updates or do changes or drops or things that will impact your data and then impact your users without them knowing or without you being sure that that's absolutely the change that you want to make, right? So in that sense, what we want to do is typically have some sort of data lab or test environment or something like that. But those take a while to configure, right? And you're essentially copying your data, you're creating a whole different environment. You've got to, deal with permissioning, putting it up, tearing it down, all of that fun stuff. With Dremio and the catalog that we've had here, you don't have to create another environment. All you have to do is create a branch off of your main branch that we've been working on. As I mentioned before, you'll see these little tags in dremiocloud that show you what branch you're working with. And so that's essentially just a pointer to the version of your data you're looking at, right? You always want main to be the one that your users are running their dashboards off of and querying when they're trying to report on something. And so you want that main production branch to always be stellar, working 100%, right? And so when you want to make a change, we're going to create a branch. And again, it's not going to make a copy of the data. It's just going to have a pointer to the data. And as we make changes, it'll be written out into a metadata file, basically. Okay. And so how you go ahead and create a branch is pretty simple as well, right? It's a SQL statement like the rest of these have been. You can do all of this in SQL, right? And so the syntax is very simple. It's create branch. You name the branch that you name the branch that you're about to create. I'm going to call it NYCETL. And it's off of the main branch. So you specify that as well. And then it's in our in our catalog that we've been working with. And for me, that's in workshop, right? So you're creating a branch off of any branch. For us, it's main, and it's going to be in the catalog of your choosing. Mine's workshop, right? Because that's the one where we've been putting our data in so far. And so let's go ahead and run this statement, and then we'll see what happens after that. So that was pretty quick. It created a new branch to verify that the branch did get created, or see, what that looks like. You can go ahead and click on the tag, the branch picker over here, and you'll see that NYC-ETL is in the other branches section, right? So if you wanted to, you could switch over to this branch, and the left-hand panel that shows your data. If you were to create a brand new table or a brand new view, any brand new objects in the NYC-ETL branch, the left-hand panel would reflect all of those, right? Now, if you swap back to main, those items would not be there. And so the left-hand panel with all of your data sets would get updated to not have the things that haven't been merged back, right? And so that's a concept as well. I'm going to keep my branch picker to say main, but basically what we're going to end up doing is making the changes to the passenger count that we talked about in our NYC-ETL branch, because it's isolated that way, not impacting production. And then when we're happy with it, we'll decide to merge those changes back to main. All right, so then everybody will have access to those changes. So another little bit of syntax that might be new to a lot of folks is when you want to do something on a branch that's not main, you'll want to specify the @branch syntax, right? So as I mentioned, we're going to make an update to the NYC trips data set, and we're going to change the passenger count wherever it is 7, we're going to change it back to 6, but we only want to do that on NYC-ETL. So simple enough. Let's go ahead and run that. And while that's running, again, large data set, it's going to take a second here to run that update across or to look through the entire data set. While we're doing that, the next few things that we're going to do is really enforce that the changes that we just made right now to NYC-ETL didn't actually impact the main branch. So everybody's dashboard is not seeing the changes from 7 to 6 yet, okay? And how we can do that is using the same syntax we just did with the @branch syntax. So at this point, I want to verify that my main branch didn't get impacted by the change I just made. So we'll specify @branch main and look for anywhere that the passenger count is 7 in the NYC trips data set. I would expect that something does come back, because we didn't make a change to main. We did it in an isolated branch. So that's fantastic. Main has remained exactly the way that it needed to, right? And now what we want to do is, I think we're pretty happy with the change. It was a simple change. Can't really think of any issues that would result as part of it. So now I'm happy with it, and I want to make the same changes that I made in NYC-ETL onto main, right? And all you have to do that is merge the branch that we just made the changes on back into your main branch. And of course, specify the catalog that you want to do this with. So you'll notice that it's very similar to Git, if any of you have used that, right? When you create a branch, you merge the branch back into your main branch so that your changes get into production. So that should be a pretty familiar paradigm for a lot of you, but let's go ahead and merge our changes to main. Cool. And naturally, we're going to verify that those changes actually made it to main, same @branch main syntax, right? And I'm running the same statement that I did earlier to verify that my changes hadn't made it there yet. So now, instead of the one row that we were seeing before, I would want to see absolutely nothing coming back. So let's run that and see what happens. As expected, passenger count equals 7. Anywhere that was the passenger count was 7 is no longer there because we've merged our changes to update that to 6 now, right? So that was how easy it was to not only create your first Iceberg table and populate it with data, but also make direct changes on your Lakehouse without making any copies, without creating a whole separate environment to isolate your changes, or, you know, even if you were doing experimentation and wanted to bring in another data source or something, you would just create another branch and give that to your users who wanted to do any sort of experimentation. So it's as simple as that, right? And this really does lower the amount of work and setup and tear down and just cost that's going into QA testing environments, experimentation environments, and all that fun stuff. So super simple, seamless experience. All of it can be done in SQL. And that's really as basic as it gets, right? Basic but powerful. And of course, the last step of this workshop is you can't have a data set. You can't have a set of data without super performance, right? You don't want your dashboards and your queries to be running for minutes or hours or any of that, right? Your end users don't have that kind of time. And so what we're going to do here is make sure that any queries on the data that we have brought into our Iceberg table, the NYC trips data, is performing well, right? Second to sub-second performance is what we're looking for, and that's what we're going to get. And we're going to do that through what we call it reflections, right? And so reflections you can think of those as materialized views, right? But again, we're not making copies. Basically, what we're doing is optimizing the data close to the query engine. And we're using techniques like compression and partitioning and sorting and columnarization, things like that, right? So that's what's going to help us, especially with our aggregation reflection, or our aggregations, our queries that run, sum and count and that kind of thing. And so we want to accelerate those specifically. And what you'll see here is exactly that happening. What we're going to do is create an aggregation reflection on top of the table that we just been working with. And we're going to specify the dimensions and the measures. And I'll show you a different way of doing this as well, but I'm going to do this via SQL statement for now. And again, notice the @branch main syntax. You don't necessarily have to put that syntax since we're working right off of main, but just as a reminder, that's how you would do it, whether you wanted to do it on main or a different branch, right? And so let's go ahead and create this reflection, right? And it does take a second to create, but while that's happening, I'm going to show you a couple of things. Actually, it's already kind of done, but I'm going to show you a few things anyway. So reflections aren't anything that's super secret, right? They are transparent to the user. So the great thing about reflections is your users don't have to change the data set they're querying to point to the reflection. They query the data set that they've always been querying. So it's completely transparent to your users. But the fun part about this is that a few things, actually. Let me go and navigate to the table that we've been working with, right? I've drilled down back in the catalog that we were looking at earlier to NYC trips that we've created, right? And if you navigate into that table, you'll see a few things. One is just the general summary, the details and overview with columns and all of that of the actual data set, right? But this reflections tab is really what we want to be looking at. And so you'll notice that, well, first of all, if you didn't want to create your reflection using SQL, you could have very well come here to do that and had more of a no-code drag and drop sort of experience where you can pick your dimension columns and your measures. But what I really did want to show you all is the reflection that I created using SQL. You see that reflected here as well. This green check means it's been created and it's ready for use, right? And you can see the footprint as well. And if you click on the history here, like I was saying, it's not something that's hidden. It's not something magical. It's very obvious to you as well when reflections are being created as a Dremio administrator. You can see the jobs that we use to create those reflections. And the same thing happens when we update those reflections, right? Or refresh them. So these are the two jobs that just ran to create the reflection that I created about a second ago. And so going back to what we were doing here, the reflection's been created, and it's been created on the table that we've been working with. The important thing to note here is, although it's created on the table, all the views that are on top of that table, we don't have any yet, but we'll create one. Those benefit from that reflection as well, right? So you're basically creating a single reflection that does a whole lot of work. You don't have to necessarily adjust every single view on top of the table with a similar reflection, right? So I'm going to show that to you. So to demonstrate that, let's go ahead and create a view. It's a very basic view. It pretty much takes everything in the table that we had and creates a view out of it, okay? And again, it's on the main branch, right? So what we're going to see after we create this view, that was easy enough. Let's expand this folder, and we have that view as well now. NYC trips view, right? Which is off of our NYC trips table. And now the last but essential part of this is verifying that the reflection we just created actually accelerates queries, right? And the easiest way to do that is have a query here. As you can tell, there's an aggregation in there. I'm going to do a sum of our passenger count column that we've been working with, and group that by the day, the pickup day, right? And so typically on a large data set, this can take minutes, right? Our NYC taxi trips data set is fairly straightforward, but on more complex, wider data sets, it can take hours to come back, right? And a lot of the times your dashboards end up timing out. Typically, you're going to have to create extracts or cubes of sorts to make that run and get performance close to what you need. But with reflections, when we query our view here, you're going to see that it goes through the million rows pretty quickly, right? In a second, less than a second. And that's the power of a reflection, is that by having one of those and specifying, the types of aggregations or the dimensions on which your aggregations are going to happen, you can get performance not only on the table that you created it on, but the views on top of that, right? Which is pretty phenomenal. It was a one-time click, and all of the views on top of that table are going to benefit from that performance. Now, the one thing I do want to show you is going back to the jobs page that we've been on. I'm going to do a quick refresh of it. As I mentioned, all the jobs that run, they show up here, right? So oh, okay, it is there. Filter problem, user error. And the thing I wanted to point out to you all is the job that we just ran is this one here. And the important thing to note is this little purple lightning bolt. That's the indicator that the reflection that we created actually was used, right? And if you drill down further into this job, you can get more information about exactly what happened, right? If you've got multiple reflections configured, different types of reflections, we have raw reflections as well, then you can see all of the reflections that were scanned or were looked at or evaluated, and those that actually got used. In this case, we definitely match the reflection that we just created, and that's the one that was used as well. And so that it's really easy to tell whether your reflections are being matched or not matched, and whether they're accelerating your queries or not. All right, so that was pretty easy. We've gotten through not only creating an Iceberg table and populating it with data and making an update to it without impacting production, but on top of that, we figured out how to get sub-second to second performance on our data and our queries running ad hoc, or if you ran the same type of query from a dashboard or a report, you would get the exact same type of performance. And so that's pretty much it. To tie it all together, you've done all of this work. Your data set is ready for your users to now query and work with. And the important thing to do there is just make it so that they can understand the data that they're working with pretty easily. And so for that, I've put together this little wiki that I'll show you where to put so that all of your users have access to it. And as you can see, it pretty much gives them a summary of the data that's in the data set, right? And of course, if they have any questions, you can replace that with your own email, but column descriptions and examples are what I like to put in my wiki for my users. So what we're going to do here is go back to the catalog view that we had and then drill into the folder that we've created. And I'm going to expose my view to my users. So basically, you go ahead and navigate to the details tab that we looked at briefly before. And there's a wiki panel here that you can pretty much freeform text anything, right? And so it's as simple as that to go ahead and add a wiki to your data set. Oops, there we go. And while we're here, the fun stuff that we've recently added, actually just last night, is now you can use generative AI to generate your wikis and your labels for you, right? And it's pretty quick as well, usually just a single click of a button. For labels, those can help your users identify the type of data set, maybe that there's PII in it and things like that. And so we've automated that for you rather than you spending time manually cataloging your data sets. You can use both the generation for labels and the generation for wikis as well. So, I can get rid of that one. I'll save those two. And so that's pretty cool too. So along with just having the wiki capability to enhance the catalog, you can also generate the wiki and the labels when you create a data set as well. So that's a nice little addition to all of this workshop. And hopefully you guys have figured out that Iceberg isn't difficult, right? It might feel like a mountain of a challenge, but it's pretty easy to get into when you've got the right setup and the right catalog that you're working with. So that's it for me.